All right, now this is the video that I'm actually going to recommend that you wait for a while before you come back and watch. So you might want to pause it here and then come back. But we are going to factor a trinomial of the form ax squared plus bx plus c in the traditional manner. Now the traditional manner requires us to get the factors of the first term, 1 and 2, and the factors of the constant, 1 and 2, and we're going to have to mix and match these factors in such a way that we get 5. Now, one of the ways that we can do this is we can make what's called a factor box. So we have the factors of the leading coefficient, I'll put those up here, and the factors of the constant here. And we say 1 times 1, which is equal to 1, and 1 times 2, which is equal to 2, and 1 times 2, which is equal to 2, and 2 times 2, which is equal to 4. We're still looking to see sums and differences, so we're looking for a sum still, and we're going to look at sums across the diagonals here and here. And which ones sum to are 5? Well, 4 and 1 sum to 5. So those are the factors that we're going to need. We found that when we make the products 4 and 5. Well, let me show you something. If you say 2 times 2 is equal to 4, and we get the factors of 4, 1 and 4, and 2 and 2, look which ones make our sum of 5. Also the 1 and the 4, the ones that we see there. So our factoring by grouping method can actually be used to do this. Now, I don't like the factor boxes because then I have to take this and I have to put it into my binomials to make sense, and that's just really hard for me. So what I like to do instead is I like to start forming my binomials. So I say, okay, well, my first term has to factor as 2x and 1x, and then I have to have my factors of my constant putting in here. So I could either put a 1 in here and a 2 over here, or I could have put a 1 and a 2 in here and a 1 over here. Now you'll notice there's a GCF here, so I couldn't have even done that in the first place because you can't put a number in there and get a GCF if there wasn't a number a GCF in the first place. So that means that definitely the 2 has to go here and the 1 has to go here. And then this is a sum, and these are both, that's a positive, so that means they're both positive. And then we can check it. 2 times 1, 2x squared. And then outside is 4, inside is 1. 4 plus 1 is 5. And then 1 times 2 is 2. And there we go. That's our factorization. Now let's try it again. So we have our next one. We have the factors of 10. Now this one's going to be a little bit different, right, or a little bit harder, right, because we have more factors. So 1 and 5, no, I don't think so. 1 and 10, 1 and 10, and we have 2 and 5. And then for 2, we have this 1 and 2. Thank goodness. All right, now I'm going to do this the way that I like to do it. So I have a choice. I can have 1x and I can have 10x. And then I can put in my factors for my constant 1 and 2 in here. Well, I can't put 2 in here, can I? Because that makes a GCF. You can't have a GCF. So I'm going to erase that, and I'm going to say, okay, well, the only way I could do it would be a 2 in here and a 1 in here. Outside would make 1, inside would make 12. 12 plus 1 does not equal 9. So this is not a possibility because there are no other factors of 2, there are no other factors there that are possible. So I'll go down now and I'll try with my 2x and my 5. And you see, the way I'm doing this is I'm making sure that my factors here belong in the first positions, right? First position here, first position here. And the factors here are going to belong in the second position. Now notice, I can't put a 2 in there, can I? Because that would make a GCF. And there is no GCF, so I know I can't have a GCF. So that means the only way that this will fit in here is to put a 2 here and a 1 here. And I know these are both pluses, because it's a sum and it's pluses. So 4 on the outside, 5 on the inside. Yep, 9. And remember our factoring by grouping method? Well, our factoring by grouping method would have shown us that if we did 10 times 2, that we would have gotten 20, and we would have had a 1 and a 20, or a 2 and a 10, or a 4 and a 5. And if we wanted to make a sum of 9, then we would be using a 4 and a 5. And look at the products that we got. Our outside product was 4 and our inside product was 5. And that's where those factoring by grouping methods can come in handy.